So today we are going to start the some
Sure,
of the
recording.
recording also
So
started.
sorry.
We'll start the discussion on the numericals on the RLC circuit. Okay, and so these are the three basic circuit elements that have been already taught, and they are actually you know present in plenty throughout the network. Okay, there is as soon as you have a wire, there is a resistance. As soon as you have a coiling, there is an inductance, and then you have a capacitance as the other circuit element. So we saw this, that if you apply an alternating source, okay, some current will flow through it, and we know that how the voltages across each of these elements individually behaves. Okay, individually behaves, and then gradually we will see that how to combine them and solve the circuits. So the combined voltage, this Vs is equal to Vr plus Vl plus Vc. Though I have just kept it in the form of a simple addition, it actually will mean addition, because all these voltages Vr, Vl, and Vc, in it is an AC circuit, they are basically in different directions in the phasor diagram. So you are already introduced to the concept of phasors. So when we add these, we actually, what we mean is the phasor addition, which is very similar to the vector addition you have already studied in your physics class. So for phasors, we all know that there is always a reference. Reference is a must, because everything that will be done is with respect to that reference. And as if the vectors are, or the phasors are rotating in the counterclockwise direction with some angular speed omega. Omega, you all know, is related to the supply frequency, by the relation omega equal to 2 pi f. So that is how the phasors will rotate. And so in this case, this is basically a series RLC circuit. That is, R, L, and C are connected in the form of a series. And if you apply an voltage source, the same current flows through all of them. So if we put the current phasor along the reference, okay, if we put the current phasor along the reference, where will VR be? VR, the voltage across the
along
resistance.
Along
same
the
side
reference
current,
line of the
Yeah.
resistance.
Along the I
along the
reference
current.
line.
Yeah. So
Yes,
VR,
yes.
VR will be aligning along with the reference phasor. It will basically align with the current. Okay. So this is the property we have seen individually for the resistive element. Similarly, you have the VL. VL is basically, it will be 181, sorry, not 180 degrees. It is 90-degree ahead of the
90.
current phasor. Okay, so that is VL. And similarly, VC, we know
Minus 9.
is
Minus
lagging the current
next
phasor by
90
uh,
degree.
90 degree. Okay, so it is
We
basically
are
lagging the value of the current. So lagging the current phasor. So now this VL and VC, the magnitude of VL and VC will basically depend upon the values of L and C. Okay. So now if your VL is greater than VC, they may be same, they may be equal, they may not be equal. Most of the times they will not be equal. VL can be greater than VC. So then what will happen? Since this is vector addition, and they are exactly in the opposite direction, so there you will get some resultant. If your VLN is greater than VC, then what will be the resultant? It is VL minus VC.
ahead of current.
It is VL minus VC, and it is ahead of current. But it can be the other way also. If it can be that your VC is greater than VL, then the resultant of VL and VC is VC minus VL, and which will be lagging the current. Okay, the similar thing will happen. So in that case, if we just choose VL is greater than VC, which will again happen in most of the cases, because in an electrical circuit there are a lot of coils. Okay, when you see inside any electrical machine, you will be taught electrical machines in the form of that basics of transformer. You will be taught induction motor. All these machines basically have a lot of coils. Some of you may have seen the inside of some machine. If in your locality, if you see some electrician shop, they may be repairing some machines or motors. If you just stop by and see, you will find that there are a lot of coils. So as soon as there is a lot of coils, there is a lot of inductive effect in the circuit. and the inductive effect is most of the times actually dominant in the circuit. So most of the times VL is greater than VC, so your result is basically VL minus VC is in the direction of VL only. Okay, but with the reduced magnitude, because VC is in the other side. VC is just 180-degree opposite direction. So this is the resultant of VL and VC, and then ultimately you will have to find out the total voltage, which is Vs. Okay, so the total voltage is basically the sum of these. Okay, so the VL minus VC and the resultant along with the VR, it will be somewhere along this direction. Okay, so your net voltage, which is Vs, you see there is some now, right now there is an angle between Vs and the current I. Okay, so Vs is the supply voltage and I is the net current in the circuit. So there is some net angle between the resultant voltage and the current. Okay, so these values of angles and all you can find out. When we do the actual numericals, you will actually get all these angles, and then using these angles you have to do the next step. Okay, so this is how you have to keep on, in an AC. It is expected that you will have to draw the phasors. Just drawing the numericals, getting them some numbers or angles is not sufficient. You will have to keep on drawing the figures. So in your next this quiz and this thing, the homework onwards, you'll have to encounter AC numericals, and then along with the calculations you will also need to show the phasor diagrams. So that is a must. If you don't show the phasor diagram, it will not be understood, and it will not be, you will get less credit, as well as it will not help. It may even confuse you to complete a numerical if you don't keep on drawing the phasors. So this is a simple thing, simple RLC circuit, and this is its phasor diagram will look like. And obviously, if your VL is greater than VC, if VL is less than VC, then you can draw the diagram. Then in that case, the VS will be lagging the current. If your VL is less than VC, then your VC minus VL will be in this direction, and the voltage phasor, that is that VS, will be lagging the current. So current will, in that case, you will have leading current. But right now, what you are basically having is lagging current. When you have an RLC circuit with VL greater than VC, the current is actually lagging the terminal voltage. That is the terminal voltage phasor. So this is the lagging current. Okay. So with this concept, we will gradually do the numericals. So one problem I discussed in the previous class. So this numerical was done. Any problem with this numerical? That was solved in the previous class. Okay, all of you remember this?
No,
Huh?
yes, sir.
No.
Yes, sir. Remember.
Yes, sir. Yes, sir. Yes, sir.
Yeah. So this is the problem I gave this network, and I told that if the source is an alternating source, there is a voltage source, there is a current source, but only in this form it is not sufficient. We gradually gave more information. We gave the value of omega. Sometimes you may not be given F, you directly given the value of omega, and then gradually I gave the values of IC and IL. So, and then something was expected. So IC is basically the current in the capacitor, which is using, that is the magnitude and the angle phase. Current unit is amperes. So you have to also be very careful about the units. Okay. Similarly, IL is the current through the inductor, which is 3 angle 53 degree. So, and you are asked to find these values. You are asked to find the value of IS. You are asked to find the value of VS, and ultimately the IR. So we started with this, since with whatever given, first you have to put them in the phasor diagram. So you are given basically this IC is equal to 1.2 angle 20. You will have to actually draw in a graph paper in proper scale. In this slides, maybe the scale may not be accurate, but when you actually draw the phasor diagram, you will have to choose some scale and draw it. Okay. So since there are two types of physical quantities will be there, current and voltage, it may not be possible that same scale works for both of them, okay, depending upon the magnitude. So in that case, you choose one scale for the current and you choose another scale for the voltage if it does not work. you'll have to adopt that and draw the phasor diagram. Because suppose the voltage current here is in the range of 1, 2, 3 and all, and the voltages may be in the range of 40, 50, then using the same scale in that paper, you may not be able to hold it. Okay, so this is the given IC, and similarly what is given is IL, which is 53 degree with respect to the reference. And then we gradually, so once you get IC, what you can find out is what? You are given this value of the capacitance, you are also given the value of omega. So what you can find out?
VC.
VC. So we found out the value of VC, and VC is what will happen? The value of VC will be lagging the capacitor current by 90 degree. Okay, so that is the property of a capacitor. So not just the magnitude, you will also have to find out the angle. So lagging by 90 degree from 28 degrees, basically 28 minus 90 degree. So that is the minus 62 degree, and the magnitude you get by this. Okay, what is the formula of the magnitude?
Sir.
Huh? Magnitude formula, what is it?
I
I by omega t.
IC by omega.
I by omega t.
IC by omega t. So your IC value is 1.2. Omega value is 1200, that is given, and the value of capacitance is 25 microfarad, that is 25 into 10 to the power minus 6. So those are there in the denominator. In the numerator you have 1.2. That is how you get the magnitude of the capacitor voltage. So once you have VC, okay, so that is the terminal voltage exactly. So as soon as you get VC with the magnitude and angle, what you do is you basically draw the VC. Okay, so obviously since this is a voltage, you can choose some other scale if it cannot be accommodated using the same scale. See, because the value is the 40 and IL value is 3, so obviously they cannot be held in the same page. So you have to adopt some other scale for the voltages. And so this is the VC at an angle of minus 62 degree from the reference. So once you have the VC, it is the same terminal voltage across the 20 ohm resistor. So you can also find out I20. And where will that phasor lie?
Along VC.
Along VC. So it will lie along VC. So I20 is the same, the VC divided by 20, and the angle remains the same. The angle remains the same. Is VC divided by 20 is the magnitude gets divided. Okay, so it is 2 angle minus 62 degree. So this is how your I20. So once you get I20 and you also got IC is given to you, what can you find out? IS.
Yes, sir.
Okay, so IS is given by this is equal to IC plus I20, and so you will have to basically solve this. We do this addition. Okay, this is basically phasor addition. Okay, if in your graph paper you can even actually just complete this parallelogram and find out the current IS, or you can do this addition, complex addition, and find out the value of the IS, which will be having some magnitude and some angle. So its magnitude is 22.33 with an angle of minus 31 degree. So IS will be lying somewhere here. Okay, my figure may not be accurate, it may not be looking like the parallelogram also. Okay, but it will be, I just try to draw it. But actually you'll have to complete the parallelogram, and it will be the diagonal of that parallelogram. So all these things you have been doing. Now once you have got IS, okay, the IL is given to you, so you can combine IS and IL to find out IR. So this is the thing, IR equal to IS plus IL. So again you will have to do this complex addition, and so IL this IR equal to IS plus IL. So these two will give you 3.99 and angle 17.4 degrees. So it will be somewhere in the first quadrant. Okay, so it will be somewhere in the first quadrant. Anyway, I from my diagram it may not look like the parallelogram, but you should just appreciate the phasors. So once you got IR, Okay, then you can find out what the Vs. So Vs is equal to 10 IR plus j omega L IL. The j omega L IL is the voltage across the inductor along this loop. So if you do this complex operation, so this complex operation will have multiplication and then again addition, and if in the case of resistance it is just the multiplication is straightforward, but in the case of inductance there will be an addition of angle. When you are computing voltage, there will be an addition of angle 90 degree to the voltage phasor, so that you have to be very careful because of that j element, because it is j omega Li. Okay, so that omega Li is basically the the scalar quantities, but ultimately this will have an angle which will be the angle of the IL plus uh, uh, plus 90 degree. Okay, so this will give the net voltage Vs, which is 34.7 at an angle of 74 degrees. So somewhere it will be here. Okay. Uh, so this voltage phasors should be having the same similar scale. Anyway, my diagram may not accurate because you see VC I have drawn 40, the magnitude was 40, I have shown like this, and VAS is have a magnitude 34, but it is looking longer. Ideally, it should be looking shorter. Okay, so but just you can do it accurately using a graph paper or even just on a plain sheet, getting all these.
Sir, excuse me, in homeworks doing while doing the homework, we have to draw the phasors on graph paper.
That is up to you. Whatever phasors you draw should look,
Convincible.
Should be convincible. Okay, so if you draw in a graph or something else, it must look accurate. If it is 74 degree.
I mean, approximately draw it up to scale.
To be on scale.
Yeah, approximately you have to draw. Suppose it has 74 degree. If you draw 74 degree in the second quadrant, obviously we will not appreciate that.
Okay, sir.
Okay, so those things we will at least see. Okay, so we have to be very careful about this.
Do we not have to use the protector for this? Say you are telling that should be accurate, angle should be accurate.
Yeah, obviously you will have to use the protector. Better if you draw accurately using protector.
Okay, sir.
But you should practice these numericals doing along with the phasor, so that you learn how to do it in less time also, to draw these phasors correctly, because there will be a lot of phasors to be drawn. Okay, so but the point is you can do some approximate, but it should look convincing. Like as I told, 74 degree. If you draw it in the second quadrant, obviously we will then think that okay, there is some problem with this student. Okay. Tell me.
Sir, in the question, the IR is the function of a T we have to calculate, but we have calculated it without.
Sir,
IR should come a function of T.
What is that? There is no T. Who will answer this question? What is your name? Who is raising this question?
Daksh Varshney.
Daksh. Okay, Daksh Varshney. And now
the theta is actually cos omega t plus that theta.
Yeah. So Daksh
is inside that notation.
So this is the notation we are following. We have in this notation you see Daksh, there is a magnitude and an angle.
Yes,
so it is basically means, suppose this magnitude is Vm. Suppose you consider IR. Suppose IR is not voltage. Okay. So magnitude is 3.99. So it is basically 3.99 cos omega t plus 17 degree, 17.4 degree. Okay.
Okay, sir.
So so you have to look into my previous notes. Why this is just a notation, but that is the very advantage in following this notation also. So you have to follow my previous notes. You have to go read the books, whichever I've referred. Why this notation? And you have to be very much convenient with this notation, conversant with this notation, because this will be coming now again and again. Everywhere I will not write cos omega t plus theta and all. Okay, so in fact, as Daksh is telling, there is nowhere t, so it does not mean that it is time varying. All those things should not be there. All those confusion. Okay, Daksh.
Yes, sir. Fine.
So this is the numerical we did in the previous class, and then I gave one numerical which somebody was asking. So I or some of you are supposed to do that numerical. Okay, I think I gave this numerical, isn't it? Is it the numerical I gave last class?
Yes, sir.
Yes, sir.
So you see this numerical, you are asked to find out the voltages V1 and V2T, V1T and V2T. Okay, so V1, you see that V1T and V2T, or rather V1 and V2 are basically these two node voltages. And what is actually given, the sources here are basically current sources. You see on the left hand side, there is one current source, which is again given by the form, again the magnitude angle form. Okay. So that does not mean it is just, there is no T or something. All this confusion you have to get rid of by reading the books, because gradually we will advancing, we will follow some notation, and that we will follow blindly. So this is actually the magnitude angle form, magnitude theta form. So there is a current source 1, angle 0, that is the left hand side. On the right hand side, there is another current source. The direction I have shown, it is 0.5 angle of minus 90 degree. And the question is, you are asked to find out the node voltages V1 and V2. Okay. Now you have to see another thing is, there are circuit elements of all types that we have studied so far. There is resistance, there is capacitance, there is also inductance. Okay. But all these circuit values, like resistance is given in terms of ohms, but other inductance and capacitance are not given in terms of their usual units. Okay, like inductance is given, is the unit of inductance is Henry or millihenry. Similarly, you know the unit of capacitance. But here you see that I have directly given the what? What I have given? I have directly given the reactances. I have directly given the reactances. Okay, for an inductance, the reactance is omega L and it is J omega L. Okay, so what I have given is directly, if you take the reactance, I have given J10, and the reactance dimension wise, the magnitude has units of ohms. Okay, but there is a J component when there is a inductor. Similarly, for the capacitor, it is 1 by J omega C. So it is 1 by J omega C. If that J in the numerator you bring it to the in the denominator is brought in the numerator, it becomes minus J. Okay, and that 1 by omega C magnitude is actually given here, which has the dimension of ohms, which has the dimension of, so for the capacitance, you see the values that are is given in terms of J 1 by omega C form, minus J 1 by omega C form. So it is minus J 5 ohms or minus J 10 ohms. That is how the values are given. Okay. So now find out the values of V1 and V2. So to find out V1, V2, which rule will you apply?
KCL.
Will apply KCL. Okay.
Current loss.
So because you are given the current source. Okay. So, but before that, let us draw again the phasor, because the sources are given in the form of a phasor, the current sources. So suppose we call this source as I1, the left one. Okay. So this is the phasor in here, lying here. The magnitude of 1 and at an angle of 0 degree. That is, it is aligned along with the reference. Similarly, the other current source, it is a magnitude of 0.5, but an angle of minus 90 degrees. So it is basically lying here. It is clear, the phasors? Okay. Now with these phasors, now you will have to find out the values of V1 and V2, and you can see that you can basically apply the node, you can do a node analysis, and that is you apply KCL. So basically, all these branches will be having some current. Okay, assuming some current direction, all these branches will have having currents. Similarly, in the middle branch where there is a parallel element, there will also be some currents. So how many KCLs will be required? You have two unknowns. Okay, you have the two unknowns, V1 and V2. So you'll have to apply 2 KCL. So applying KCL at the left node, you see that if you apply KCL at the left node, the current going in is 1 angle 0, and all the other currents are basically going out. So what will be your KCL? 1 angle 0, that is the incoming current. current going to the node is equal to the sum of all the outgoing currents. So what is the first outgoing current? What is the first
V1
outgoing?
and theta 1, V1 and
V1 by
theta
5.
V1 by 5.
V1 by 5.
Then
V1 by 5.
plus V1 by minus J10.
10.
Okay, plus
Yes,
plus
sir.
V1. So this is outgoing. So minus J10. You have to be very careful what I am writing. V1 by minus J10. Okay, but here there is a plus. And then what is the current in this branch?
V1 minus V2 by
V1
minus
minus
J10.
V2 by minus J5. Similarly, V1 minus V2 by J10.
G5.
So you see, so if you apply KCL in the left node, so then you are still left with another thing. So there is V1 minus V2 by minus J5 plus V1 minus V2 by J10. Okay. Similarly, so if you simplify this, do you get this form?
Yes, sir.
Just check, my calculations also may be wrong, so I want to get it checked by you. Don't take it blindly, the equation I've written. So 1 angle 0, this basically means 1 cos 0 plus j sin omega, j sin 0. So sin 0 is 0. So in the right hand side, you have 1 plus j0. So if you write it in the form a plus jb form, you basically have this. So what is the KCL at the right node? Applying KCL at the right node. What will be the equation? So you see this current, the right current is 0.5 minus 90 degree and it is going down. Okay. So if we consider the direction upwards, how will it affect this value? There is the minus sign. Okay, instead of 0.5, if we consider this current source, the right hand side current source is, if we consider the right hand side current source to be if the right hand side current source is assumed to be going up, okay, so in that case, what will be the how will it affect this value? If we change the direction, it will become minus
Negative.
0.5. Okay, minus 0.5 angle of minus 90. Okay, and then it becomes a current going into the node. Okay, and you can apply your this thing. So you see the current going into the node is minus 0.5 angle minus 90 is equal to the current going out. So current going out is, first one is V2 by 10. The second one is V2 by J5. And in this case, if you check the direction in the other direction, it becomes basically V2 minus V1 by J5. V2 minus V1 by J5 and by minus J5. Similarly, V2 minus V1 by J10. So how will this look like in the form of just coefficients of V1 and V2? Just as the coefficients of V1 and V2, how will it look like?
So in the form of J and normal real number complex. So V2 equal to minus 10 by 17 plus 40 by 17J.
Minus? So ultimately these are the two equations now you will have to solve. Okay, these are the two equations you will have to solve by you'll have to solve, and where the coefficient you see it is similar to the algebraic solution, but the coefficients are complex. So the coefficients are complex. So whatever V1 and V2 we will also get are basically complex values. Okay. So tell me the value of V1 and V2 in terms of, ultimately that complex number also can be expressed in terms of a magnitude and an angle. Okay, so what is V1 in terms of magnitude and angle, and V2 also in terms of magnitude and angle?
Can we equate real parts and imaginary parts?
Huh?
Can we equate real parts and imaginary parts?
No, we cannot.
No, it is also phasor now.
See, your ultimately your variables, your unknowns are V1 and V2, and the coefficients are basically complex, and the right hand side is also complex. Okay, so whatever V1 and V2 will get is also a complex number. That complex number you will have to find out by in the magnitude angle form. You can apply Cramer's rule also. Okay, you can apply Cramer's rule also. So ultimately V1, V2 will be complex, and ultimately I want it in the form of magnitude angle form, and once it is magnitude angle form, you can also put it in the phasor diagram. The purpose of magnitude angle form is it is in that at that angle with that magnitude to some scale you can represent it in the phasor diagram. So what is the value of V1?
Sir,
Hmm.
sir, if we use mesh current law, we can wrap it up in one variable.
One variable or 100 variables, whatever it is, you know, ultimately the question is to find the node voltages.
Sir, but in this method we are having two variables we have to solve. In mesh we can do with one variable only.
Okay, so what is the value of V1?
I have not found it. I was just thinking.
No, there may be other efficient ways also. It is not that this problem can be done by one unique way. Either you can do it by some other efficient way, but the answer will be unique.
Okay, sir. I'll check it.
V1 is how much?
Sir, V1 is 1 minus 2j and V2 is 4j minus 2.
1 minus 2j, one magnitude?
Root 5. 2.23.
Sir, 2.236.
And angle? You have to
Minus
tell both.
63.
If you don't tell both, you know, you'll get half credit actually. This is AC, phasor,
2.23 minus 63 degree volt.
and V2?
Minus 63.43.
And V2?
Yeah. And sir, V2
4.47 and 106.7.
116.5.
Yeah, so you have to the first thing is to write down the equations correctly, because this is AC and you know so we have learned how to represent in the magnitude angle form, which actually helps in the calculation. Then we also have learned what are the values, how to represent reactances. Okay, instead of the actual circuit elements, you are actually directly given the reactances because you are not given the value of omega here. Okay, if you are given the circuit elements, you need omega. But here that omega is not given directly, you are given the reactances so that you can solve it. So ultimately you get what? So solving the above equations, you get V1 equal to this type of value, 2.24. Okay. Is it okay? The answer or some other answer is there?
Yes, sir.
The current.
Current.
Correct.
So correct. So you know, so again it is in the phasor diagram. Okay, so it is at minus 63 degree from the reference. From the minus 63 degree from the reference means it is in actually in the fourth quadrant and with some magnitude 2.24. Similarly, the other one V2 is 4.47, 116 degree with plus 116 degree, 16.6 degree. And obviously that voltage you have to write because this is a voltage. Okay, the physical quantity is voltage. That has to be written. So 116 degree is where? It is, what is 116 degree?
180 degree out of phase with V1.
180 degree, correct. Who told this? So you see, 160 degree is just 180 degree away from minus 63 degree. So it is obviously in the second quadrant. Okay, so this is this. So the V2 is lying here. Okay, so that is how that was the thing that was asked to you to solve the circuit and find out the voltages V1 and V2. And since this is AC, you will have to basically give both the you have to basically give the phasor that is represented in the form of a magnitude, and you have to give the magnitude and also the phase also. Okay.
Not getting the angle of V1.
Huh? Angle of V1 is
Angle
wrong.
V1. Sir, I'm getting minus 33.
Minus
33
33
degree.
degree. Minus
Sir,
33
it
degree.
is right. So the answer, I mean, the angle is correct here.
Okay, so anyway, so you check, whoever is getting minus 33 degree, your friends are all getting this. You check your calculation, and the calculation has to be, perfectly done. If your equation formulation is wrong, then ultimately you'll get. You can even apply Cramer's rule to get all this thing, but only thing is the values are complex. And you have to use them properly. You know what is the value of
But the
J. What is,
complex number of V1, then how to
uh,
calculate the angle?
tell me how to calculate the angle. Suppose you have A plus JB. What is the magnitude? If you have a
Under root
complex
A square.
number, then what is the angle?
Tan inverse.
Tan
Tan
inverse?
inverse
by
B by A.
A plus JB. What is the angle?
Tan
Sir,
inverse B
tan
by A.
inverse.
Tan inverse B by A. So so you have to first do B by A, then find tan inverse using the calculator.
Sir, 1 second, sir. You told that we can't equate the real and imaginary part. Means if we means we have to just take the modulus and then calculate it.
No, I am not telling. You have to ultimately solve these equations. And the equation is having complex coefficients. Okay, so you have to solve the equations in terms of the variables and which is having complex coefficients. So your answer will also be complex, or something else will happen.
Sir, why can't we solve it by equating
V1
the
and
real
V2
part
are
and
also
equating
complex.
the complex part?
V1 and V2 are also
V1 and
complex.
V2 are also complex. That's why we are not equating.
How will you equate? What do you want to equate?
He-
The coefficients are different. You are given two equations to solve out of, so there are two equations, two variables. So it is just like solving another, you have already done, suppose you are given, ax plus by equal to c, and then px plus zy equal to q. Okay, so how do you solve it? It is something like that, but only the values are complex. The coefficients are complex. Even your right hand sides are complex. Okay?
Okay, sir.
So these things you have to, you have to do correctly all this calculation, and all this you are seeing that everywhere there is the tan inverse, modulus, all these things are coming, which may not be normally. Even it will not be. You will most of the times you will not have nice modulus to find out. 3 square plus 4 square equal to 5 square equal to root over 5. 25 is 5. You will not get such nice values almost 100 times. Okay, in 100% of the cases. So your calculator is a must. Okay, so let us go to the next numerical. So today I have decided that I will only do numericals, so to give you a glimpse of the different types of problems possible, and the similar problems you will have in your tutorial sheets and books full of these types of problems. So, as someone was asked, so the magnitude angle form, it actually means V1t equal to 2.24 cos omega t minus 64.4 degree, 63.4 degree, since the angle was minus 63. Similarly, V2 is 4.47 cos omega t is plus 116.6 degree. Okay. So, let us do the next problem. But here you have to see this thing. I already told that the value of omega is not given because I have directly given the reactance values. I have directly given the reactance values, so the value of omega is not given. Otherwise, I had to give the value of the omega v as we did in the previous numericals. or we can give the directly the value of frequency, that is f omega equal to 2 pi f. Otherwise, we will not be able to find out the reactances. But here, in this problem, I have directly given the reactances. And also,
Sir, in this phasor, sir, the line V1 will be longer than the line of 1 ampere current. I think
that will happen if we follow the same scale, because voltage is one type of physical quantity, current is another physical quantity.
No, sir, okay. I'm just saying that the length of the V1 line, sir, will be greater than the length of the 1 ampere line. Na? You told in the phasor diagram when you are.
If we choose the same scale, suppose I choose the same
sir.
scale, if I choose the same scale for voltage and current, it has to be longer.
Yes,
okay,
sir.
but I because they are two different physical quantities, I may take a less current. I can choose a different scale also. Because right here you are having voltages 2 volt, 4 volts. In actual electrical circuit, the voltages may be 100 volt, 1000 volts and all. So if you want to put the such voltages in when the current is 1 ampere, 2 ampere, you cannot hold it in one paper. Okay. So then the obvious choice is to adopt different scales for the different physical quantities, because current and voltages are different physical quantities. Clear?
Okay, sir.
What is your name?
Anal Jyoti, sir.
Oh, Anal Jyoti. Okay. Anal Jyoti, you are from Deoghar? Huh?
Yes, sir. Yes, sir.
Anal Jyoti, you are from Deoghar. Okay. Okay. There are so many people from different parts. I am enjoying the class. Are you enjoying? Or it is boring?
No, sir. Enjoying, sir.
No,
Yes, sir. We are enjoying, sir.
Okay. So the next thing, let us go to the next problem. Okay. So the question is, construct a phasor diagram showing IS, RN, IC for this circuit.
Hello, sir. In the last line, it is written that frequency must be same. Why is that?
This also I have told. Anal Jyoti.
Yes, sir. You told, sir. No, sir. I am not asking, sir.
Why is it same? So who can answer this?
Sir, because sir, you told that in India we just consider value of frequency same, then the radian omega will also be the same, sir. We cannot take omega.
What is the question?
Sir, in
why is the frequency
same? Does not change, sir. Only phase
so because it depends on the sources and won't change.
Omega equal to 2 pi f. F is fixed for a current country, and we are not considering the sources having different frequencies here. Okay. And if it is a different frequency, the phasors are rotating in different speeds. We cannot represent in the same phasor diagram. Okay, so in a particular phasor diagram, in a particular circuit, the frequency is the same. Because it is if you see this circuit, it is just the same circuit with both the sources with the same frequency. Does it answer the question?
Yes, sir. Thank you, sir.
Okay, so let us do the next problem. So this is the problem. Construct a phasor diagram showing IR. Okay, the value of current in the resistance. IS, that is the source, and also to show IC, the capacitor current in the phasors. Now you see here again, this circuit is different. You see the units. For the resistance, the unit, the value is given as 0.2 S. For the capacitance, it is J.3 S. For the inductance, it is minus J.1 S. What is the meaning of S?
So the Simon.
Ohm inverse.
It is the reciprocal of resistance.
Yes, sir.
Okay.
Yes.
If it is the reciprocal of resistance, it is basically conductance. Okay. So S stands for Siemens. Okay. SIEMENS, Siemens. So Siemens is the unit of conductance. Okay. So some of you maybe once you graduate, there is a company called Siemens. Very very good company on electrical, in electronics,
yes, sir.
products and all. Okay. They have a lot of products in electrical, electronics, automation. So some of you may be opting for that company. You may get a chance to join, and if you get it, you should join. You learn a lot of things from that. So that is basically big multinational company producing large electrical equipments and automation systems. So it is basically a German company. So Siemens is a German company, and so Siemens is the unit of conductance. So
Sir,
here
its
you
office was beside our school.
Huh?
Sir, its office was beside our school.
In Kolkata?
Yes, sir.
Yeah, I know that. Which school? You are in some DPS or something? Huh?
Yes.
It is beside DPS, Kolkata. UB Park. Yeah. So that is a big company. Similarly, they will have branches in all other cities also. So Siemens is basically the unit of conductance. So here you see that the units are given in the reciprocal form. So earlier you saw that for the capacitance it was minus J, but here it is given as plus J, 0.3 Siemens. Similarly, the inductor is given as minus J. So why is it happened if you do the reciprocal of that?
When we do 1 by of a complex number, it becomes minus of I. I mean minus J.
Yeah.
So that's
So I would suggest all of you now to complete this, to draw the phasor diagram. So you see here, so the voltage across the resistance is 1 angle 0 volts. So obviously it is along the reference. So if the voltage across the resistance is known, what is the current?
0.2 ampere.
0.2 ampere. So in that case, what will happen? You will have to multiply voltage with this conductance. Okay, it is multiplying the voltage with the conductance. So your IR is basically 0.2. And where will it be? It will be aligned with the reference. So IR is equal to 0.2 into 1. And this is equal to 0.2 at an angle 0 degree. So this is your IR. Okay. So you got IR. So can you find out IL? Now across the inductor, what is the voltage?
0.2.
1 volt. So 1.
1
volt. Minus 90.
1 volt. So where will be the inductor current?
90 degree
minus 90 degree behind the face.
Yeah, 90 degree behind the current.
So minus 90.
Minus 90 degree.
Find out the inductor current. IL equal to
IX minus IR.
0.1 angle.
0.1 angle minus 90.
Sir, minus 0.1 angle minus 90 degree.
Angle minus.
So you will basically do this. Okay.
Yes, sir.
And this will give you what?
Yes, sir. It will give us 0.1
minus 90 degree. Minus 0.1 minus 90 degree.
Minus 90 degree.
Yes.
So phasor, where is the phasor?
Sir.
Minus 90 degree.
Downward.
Downward. Okay. It is exactly between the third and fourth quadrant with a magnitude of 0.1. Here I have tried to, IR, this 0.1 was 0.2. So this I almost tried to make it half of this.
WhatsApp.
Okay. So once you got IL, you also got IR. You can find out what?
IX.
Because IX is equal to,
The sum of
find out.
Under it
plus IL.
IL square.
Sir, 0.223.
You can also find out IC. What is IC? The voltage
0.3.
0.3 angle 90.
0.3 angle 90. 3 angle 90.
Angle 90, sir.
So how much it is?
Sir, 0.3 angle 90.
So location, phasor location.
Plus 90.
Upward 90.
Negative
At a 90 degree upward.
90 degree upward. Next, what can you find out? You find out IC, you find out IR.
IX, sir. IX, sir.
IX. Ix is how much?
IL plus
0.223 and
Sir, 0.223 angle minus 45.
So you do. So this is
0.223.
IR plus IL.
Yes, sir.
IR you already found out 0.2 angle 0.
Sorry. Yes.
IL is 0.1. Yeah. So what is the value?
0.223, sir. 0.2236.
No, but this is the complex one.
6.56 angle minus 26.565.
Minus.
Okay.
Yes, sir.
Phasor
Yes, sir,
notation.
yes.
Phasor
Yes.
minus 26 degree. So it is basically a combination of IR and IL. Okay. If you complete the rectangle, it will be along the diagonal. If you complete the rectangle considering IR and IL, it will be basically along the diagonal. Okay.
नींद आ रही है वीडियो ऑन रख के सो जाओ see you
Sir, would there be no potential difference across inductor due to current source?
What?
Sir, will there be any potential difference across inductor due to current source? Yes.
Why?
Now, across the inductor, see, inductor, resistor and capacitor all are in parallel. Na? So I have given you the potential across the. So that is actually the starting point. The potential across the resistance I have given, and we are gradually we are calculating backwards to find out what is the current source. That is the question.
Sir, I got it. Yes, sir.
Okay, so now you have got Ix. Okay, which is the combination of IR and IL. So Is is what? Is, the source.
Sir.
Combination of
resistances and conductance will be given in the form of J and minus J, or will we have to consider?
Which one?
Sir, in each question, resistances and conductance will be given in the form of J and minus J, or will we have to understand that?
No, something will be given, but in which form it will be? There can be in multiple forms. You can be directly given resistance, inductance, capacitance. Okay. You can be given.
Like that it is given in the form of J minus J.
No. First, listen to me. It can be given directly resistance, inductance, capacitance. Then you will have to tell what is the system frequency, or the omega, or it can be directly given in the form of reactance. Just in the previous problem, in the Jx form. Or this is another problem where it is given the reciprocal of the reactance. Okay.
Yes.
Which we called a susceptance. If you remember my earlier day notes.
Yes, sir.
So this problem is given in the form of susceptance, but whether it is in which form it is given, you will have to understand by looking into the units.
Okay, sir.
Here you see that even the resistance is given as 0.2 Siemens. So obviously it is a resistance, but I have given you the conductance value. So obviously some form has to be given because it is a numerical. But there can be several ways to give, which we are trying to do by different examples. But you will have to do the correct interpretation. Okay. So this is the value of Ix at an angle minus 26.6 degree. The magnitude is 0.224. Obviously, you have to write the units, ampere. Then after to get Ix, what you can find out? You can combine Ix and Ic to get Is. Okay. Okay.
Sir, actually I had doubts, sir, not regarding this question. So can I ask?
Tell me.
So actually using scientific calculator, so when I find the value of root 5, so it is showing only root 5, sir. It is not showing in decimal places, sir.
There is an
There will be
option
an
of
S to
S
D
to D.
converter. Just click on that.
So yeah, these things will be better understood, even answered by your friends. Even I may not be able to answer.
You should probably change the mode, right?
The calculator.
45 degree. Is the answer for IS 0.28345 degree? And
Let me see, because my computer again has hanged. Obviously, there is an answer, but
I'm getting that answer.
Sir, answer is coming 0.2825 angle 45.06 degree. 0.2825 and 45.06 degree with respect to the reference line. For IS.
IS. So what is IS equal to?
So 0.2825 angle 45.06.
So I'm getting exactly 45. I have actually added ICIR.
Exactly. Sir, exactly.
I'm not getting
with IA.
I got 45.06123874.
You did.
If you add IX,
I added IC and IX.
Don't use
If you add
we can find
0.2 minus J
So you see,
0.1
yeah. So you have to basically add this. You can do by your ways you learnt in your school by completing the parallelogram. So basically, you have to add this. Okay.
So I
IX is
take the resultant of IC, IL, and IR.
So basically, it is IX plus if you put the IC here at the tip of IX, the same. If you put this and then you join with the origin, then that is basically the resultant.
Yes, sir, but this will be slightly wrong, sir, because this is IX is an approximation. So instead, if we use IR plus IL plus IC,
Yes,
that
sir.
Why
plus RC, yes, sir.
No, why is IX an approximation?
no, sir, because 26.6 degree is not exact 26.6.
You want to do the whole, yeah.
Magnitude is also.
Just add all of them together.
Yeah, since they're at 90 degrees only, so
Yeah.
it will be easier for us.
Okay, you can do that. You can do that. So ultimately, somewhere close, you will get the answer. So basically, we had this. How much is the difference? If you
No,
do
it's
all
not
the
much, but I mean, we are getting exact
It
45.
is 0.06
but-
degree difference for the angle, and yes, sir, it's 0.06 degree different only.
0.06 degree.
Yes, sir.
Yes, sir. Yes, sir.
And magnitude?
So magnitude is coming 0.2825.
Anyway, so
mine is coming to 0.2828.
yeah. So anyway, if you do by this, okay, that amount of so that will also happen. You can see the same if you do by the exact addition, and if you do this type of addition, there will be these small differences because in the previous step you are also truncating somewhere. So that amount of error we allow. So this is basically having a magnitude of 0.283 or point whatever 2822 whatever you are telling with an angle of 45 degree, and so that is how it completes the phasor. Okay, IS equal to. Okay.
Yes, sir. Understood.
So
yes, sir.
So the purpose of doing these different examples is, to handle different types of sources, to handle different types of units of the circuit quantities. Not just a RL and C will be given, those things you knew from your school days, but gradually we are, showing other ways also to represent them and actually use them in the expressing these type of units in Siemens may be somewhere advantageous. Okay, when you are finding out currents. Okay, when you are directly instead of if it is given in the form of a reactance or resistance, you have to do the division. But if you are directly given in terms of conductance or susceptance, you are basically doing multiplication. to find the currents. Okay. So, can you hear me?
Yes, sir.
Yes, sir.
Let us do the next example. Yeah. So this is another example, where again the values are given in terms of resistance and reactance, and there are given three voltage sources, three AC voltage sources, and you are asked to find out the values of the currents I1 and I2. You are asked to find the values of the currents I1 and I2 for the three voltage sources. So see, as soon as like the earlier problems, since it is given in the form of it is an AC problem and some information is already given, you'll have to put them down first in the phasor diagram. Okay, and in the here you are given three voltage sources. V1 is 10 angle 0, V2 is 15 angle 90, 15 angle 90, and V3 is again 20 angle 0. So you see V1 and V3 are having a same phase, and that is also 0 degree. So they are both aligned along with the reference. So if your V1 is here, V2, V3 will be exactly double the magnitude, but aligned along with V1. But your V2 is 90 degree ahead of both V1 and V3. So your V2 will be somewhere here, 1.5 times V1 and of V1, and but 90 degree ahead. Similarly, V2, V3 will be aligned along the reference, aligned along with V1, but having a double magnitude as V1. Okay. So I would ask all of you to solve this circuit.
Excuse me, sir. So actually, when there is a DC circuit, so then we subtract from V1 and V3. So here we are adding V1 and V3. So why so it is?
No, I have not added. I have not done any addition. There is no relation with. There is no relation. There is no relation with DC circuit here. I have just represented V1 and V3 in the phasor diagram.
So, we should only follow the phase.
Huh?
So we should only follow the phase angle, sir, in this AC circuit, sir.
Phase angle is very important. Without phase, it is meaningless actually. Okay, it may be 0 degree, but it has a meaning.
Okay, sir.
Sir, I just wanted to ask one thing. In the questions that we will do in the coming tests, in the phasor diagrams, do we have to draw all phasors or ones that are only relevant to the problem? I mean, if we are drawing all the phasors, it becomes very cluttered and hard to comprehend.
What is the name?
Sir, I am Shoham Chakraborty.
Oh, Soham. See, if it is a problem, all phasors are, one is interrelated to the other. Is it like without drawing one phasor, you can get the next one?
No, sir, not really.
So it will be expected that you show all. It will be cluttered, I understand. We are yet to go to three phase and all, where it will be more cluttered. Okay, but somehow you have to do it neatly and show that there is something. Otherwise people may assume that as if you have deliberately missed it, or you are doing something from memory or something without showing that thing. Okay, if there is a physical quantity appearing, and just like the earlier problem, we were drawing one current after another. So each current, when you deduce a new current from the previous ones, obviously it is a new phasor.
Yes.
Okay, so even like the earlier example, as some of you are telling that, suppose some of you didn't find out Ix, that would not have been a problem. because your question was IS only. Okay, so IS is nothing but IC plus IR plus IL. Okay, if somebody
Yes,
did
yes.
not, if somebody did not found out IX, that is okay. That way, if Soham, you can remove your lessen your clutter. Okay.
Yes, sir, understood.
But the purpose was just to show that they get added and all. But in fact, this problem you may not have found out IX also. You could have directly found out IS and show in the phasor diagram. Okay.
Sir, we can
Or you could have,
solve the
or you could
without
have even just 1 minute. Let me tell something else. Suddenly it came to my mind. I'll go to your question. So even for this question, you see IL and IC are 180 apart. You can even quickly found out their resultant and then combine with IR. That may be useful. Okay.
Yes, sir.
So then you don't need to even go to the fourth quadrant. Actually, all your work is done in the first quadrant only.
Okay, understood. So we'll find out IC minus IL phasor, then directly plot it.
And directly plot that is again it is just a rectangle.
Yeah,
okay, it may be easier to find out. Just applying tan inverse, you get the angle and all. In fact, you can try and find out. What is it? Just like okay, we can even do it orally. You see, IL is 0.1, IC is 0.3, so the value is 0.2. The resultant of IL and IC, and IR is also 0.2, so it is tan inverse 0.2 by 0.2, tan inverse 1 equal to what?
45 degrees.
45 degrees. So you can do it orally actually.
Yes, sir.
Okay. All of you can understand this? This IL and IC 180 degree apart, and their value is 0.3 and 0.1. So the resultant is 0.3 minus 0.1, and that also capacitive. So capacitive current will dominate with the magnitude of 0.2. Okay, and then your IR magnitude is also 0.2. So that triangle is basically an isosceles triangle with two sides 0.2, 0.2. So the angle becomes 45 degrees. So even this problem could have been done orally. Okay. Only the magnitude is 0.2, 0.2 whole square and 0.2 square plus 0.2 square, and that square root should give you the magnitude. Okay. So this can even be a quiz question. Okay, if somebody asks what is the angle of IS, and the same question is given, and there are 4 options. 45 degrees is one of them. And orally also it can be done.
Yes, sir.
Okay, so somebody else was asking some question.
Generally, some questions without phasor also we can solve directly by using complex analysis.
You can draw without phasors. Some questions maybe something can be found out, but in any AC question it is expected you show the phasor. They will have some credit, and if you just give the values and all and without drawing the phasor diagram, then you will lose some credit.
Okay, sir.
So this is the thing we did. So since now you see all of you, we are gradually advancing into this subject with AC, phasors and all. I would suggest all of you to study and practice this topic on the different topics we are doing it, so that you don't get confused with DC and all. Because some of you, there is a chance that you get confused with DC, but anyway, DC is also there in your syllabus. There will be questions also on DC. But DC, AC, how to handle the problems, how to handle the different types of units, different types of representation of the circuit elements, as we are showing. You have to
Sir,
be very.
I2.
I2 is how much?
Sir, I2 is 7.08 angle 214.1 ampere.
7.08
angle 214.1 ampere.
7.08 angle 200.
14.1.
214.1.
It is
Sir.
third quadrant.
Third quadrant, okay, and maybe it is correct. I have the angle
Sir,
in the
I
negative.
minus.
And what is I1?
I1
Sir,
50 angle by
50.
yes sir,
Sir,
50 angle minus 73 point.
I1 4.86 angle 195.43.
Angle 195. Angle, if you consider the negative angle, what is the value?
Okay, wait.
Minus 15.43.
No.
The value of I2 in negative is minus 146.
Huh?
Sir, I2 is a negative angle of minus 146.
That type of thing, yes.
Okay.
So ultimately, yeah, somebody was telling 195. What is the angle in the negative side?
164.57.
Yes, minus.
Minus and
Yeah.
magnitude 4.86.
Yes, that is the value. Yeah. But anyway, that is my value. Again, if my calculation, both of our calculation is wrong, then some other calculation will be correct. Okay, so if you are considering this type of loop, okay, if you consider, what will be the equation? So considering the mesh 1, the equation is, suppose we go along this. So it is in V1, 10 angle 0.
Yes.
Then minus
Yes, sir.
J5 I1.
Minus J5 I1.
Okay, then through this 3 ohm, it is basically I1 minus I2. So again it is minus 3 I1 minus I2.
Minus.
Then to this voltage source, what is happening?
Minus
V1
minus
minus
is problematic.
minus
50.
Huh?
Sir, the V1 terminals are unclear.
The terminal is the top one is positive, lower one is negative.
Acha, because both are given negative.
No. Maybe it is not visible to you there. Maybe I will make it bold.
No, sir, it's given that.
For some it is not visible. Huh? So that is how you get one type of equation. Now you have to write down, because there are two unknowns, I1 and I2. You require. So what is it? If you go along this plus 15 angle 90, then in 3 ohm what is happening? Voltage is?
Sir, plus 3 I1 minus I2.
Plus 3 I1 minus I2.
Yes, sir.
And then minus 4J, minus of minus 4J I1. Because there is a voltage drop. Minus of minus 4J I1.
I2, sir. I2, no, sir.
Yes, sir.
I2, sorry. I2 is written, yeah. And then in V3, what is happening?
Minus 20.
Minus 20 angle.
Minus 20, sir.
Okay, so now you solve these equations. Solving these two equations. So this type of equation is okay. Whatever value will come. Whatever point is, the point is, we are in AC. You have to first correctly write down the equations correctly. There is reactance, resistance. Many things are coming now, and we have learned the notation. So first correctly writing down the equations and then solving them for the unknowns. Okay, you can even make use of Cramer's method and all to find out the correct value. Okay, I don't know whether these programmable calculators can handle all these complex numbers or not, but you have to ultimately solve it. So solving the above equations, what we get? Your I1 is this 4.87. Okay, this value is correct. I don't think this value is correct.
Yes, sir.
There will be minus 164.
Minus 164, no?
Yes, sir.
And I2 is? This value is wrong actually. Sorry.
I1 will lie in the third quadrant.
I1 will lie in the
Yes, sir, third quadrant.
Third quadrant. My value is wrong.
So the screen is not visible.
Yeah, I have stopped the sharing because there was angle was wrong in my this thing.
Okay, sir.
So this I1 will be, just let me correct it. Okay, then I will share it again.
Okay, sir.
What is the value of I2?
Sir, minus 3.75.
No. Somebody told about that. No, 7.17.
7.08. 7.47.
Hmm.
Sir, what is the angle?
7.44. Sir, I can't see the slide anymore.
No, I have stopped sharing
Yes.
because there was a mistake in my slide.
Sir, what is the I1 answered? Is it minus 3 ampere?
No.
Achha.
Just 1 minute.
Is I2 7.17 angle minus 144.9?
Yes. Yeah. Let me share the slide. Can you see the screen?
I1 is 1.48.
Can you see the screen?
Yes, sir.
Yes.
Yeah, so we did up to this. And this was the current. I1 is equal to 4.87 minus 164.6. Is it all of you got this current? You got this value?
Yes, sir.
Yes, sir.
Yeah, so this value will
Yes,
be,
sir.
so it is basically somewhere along here. Okay. And similarly, the
Yes,
you
sir.
get,
I1, I am also getting this.
yeah, so I2 is this. So if you complete the phasor, it is at an angle of minus 144 degree, 144.4 degree. So it is again in the third quadrant. So it is somewhere here. And that is your I2. I2 magnitude of I2 is close to double the value of I1. Okay.
It's
Huh?
So 44.93.
coming near 7.08.
44.9. Yeah. 44.9 may be correct. Yes. 144.9.
Sir, and the
Okay.
magnitude is coming near 7.08.
So that a small amount of
No, sir,
difference
I'm
we
getting.
will.
No, it's
Sir,
7.1.
I'm getting exact 7.169, sir. I'm getting
Okay.
7.169. That is 7.17, sir.
7 and magnitude and angle?
Angle, sir, I am also getting
Angle
same, sir.
144.93.
144.9 anyway. This I will correct it later. It is 144.9. Yeah. Okay. This 144.9 or 93. Okay. So this is how you know the phasors we have to be developed as you do the numericals. So let us do the next problem. How much time is left today?
20 minutes.
20 minutes.
40 or 20?
20 minutes.
20 minutes.
20.
Okay. So let us that find the
20.
this is the problem given. Find V1 and V2 for the circuit below. And here again you find that sometimes when there are current sources, you see that working with the working with the conductance or working with susceptance becomes easier. Okay, you are directly given that. But here you have to be careful. The current sources are given in milliampere. Similarly, the conductances are given in millisiemens. Okay, so find V1 and V2. Obviously, which method will you apply?
So nodal.
Yes, yes.
Nodal and
Yeah. Do this and let me know.
Nodal.
Sir, which direction is I2? It's a bit hazy here. I2
Left to
and
right.
I1.
Left to right. I1 is from bottom to top.
Okay, sir.
Rahul.
So whatever is given, as soon as if you draw it in the phasor, it looks like something like this. You have the I1 with an that is angle 0 and magnitude is 20. So it will be lying along the reference. Similarly, I2 magnitude is high. It is 2.5 times of I1, but it is lagging I1 by minus 90 degree. So where will it lie? It is lagging. It is lie somewhere here. Yeah, so then what do you have to do? Obviously, you have to assume some current directions. So what is the equation at node 1?
So 25 V1J plus 25 V2J is equal to 20 plus 50J.
Yeah, anybody got the answer? V1, V2? You have to be very careful writing down the equations and then handling these units. Then solving complex equations where the coefficients will be complex.
Sorry, is V2 1.592 angle minus 62.65?
1592
Yes, 1.592 V2
angle?
minus 62.65.
Your angle is wrong. V1?
I'm finding circle.
Sir, V2 is 1.26 angle minus 141.34.
No.
So the V2 is 2.55 angle minus 101.3.
No.
So V2 is 0.50 degree.
No.
V2 is minus 49.96 degree.
No.
Sir, is V1 1.26 minus 114.36 degree?
No.
Sir, V2 is 8 angle 51.34 degree.
No.
Sir, V1 is minus 46.37 degree.
No. No.
Sir, V2 is 1.5926 angle minus 49.96 degree.
Yes. What is your V1?
I am calculating.
What is the name?
Saptarshi.
I have also said that.
Who?
What angle B2?
Minus 49.96 degree.
No, I got Saptarsi's answers correct first time. Saptarshi, what is the V1?
Sir, I'm calculating it.
So it is very much important to correctly write the equations.
Sir, V2 is 87.27 degree.
No, not so high.
Sir, V2's angle is 51.34 degree.
V2?
Yes, sir.
Plus or minus?
Plus.
No.
Hmm.
Sir, is V2 3.449 angle minus 42 degree?
No.
Okay.
So all of your, equations, if they are not correctly written, you will get actually wrong answer. So suppose at node 1, what is happening? The current going in is this current I1. This is the current going in. And all the other currents are going out. So this is equal to 20 angle 0 is equal to the first current going out is J5 into V1. And you have to be very careful. The current is given in milliampere on the left hand side. So right side the unit is millisiemens. So that way it is okay. Into V1. So V1, whatever V1 you will get in volts. So because this unit is already taking care milli. You don't need to explicitly multiply 10 to the power minus 3.
Sir, is V2 1.55 minus 73.1?
No. So this is the first.
V1 1.
No, this is the first current going in, going out.
1.06.
Yes. Angle?
113.2 negative में.
Negative में 113, no. So this is the first current going out. The other current going out is suppose from this J25 millisiemens, minus J25. This is an inductor, so minus J because it is in the expression Siemens. Okay, so this is minus J25 in multiplied by V1 minus V2. The terminal and the voltage difference. And then there you have the I2, which is also going out. If you consider node 1. So it is plus to this. So on the right hand side is all the currents that are going out. We have added it. So this is the equation considering node 1. Considering node 2, the equation is this node 2. The current going is this I2 is going in 50 angle minus 90 degree. And the currents going out are to the 40 millisiemens resistance, and there is again through this is current coming in. So this inductor, the current is coming in. Okay, so how much is coming in? Minus J25. Minus J25 V1 minus V2. But there is a minus. Okay, though it is a current coming in, we are calling. So it is minus J25 V1 minus V2. So it is current going this direction from left to right to the minus J25 millisiemens. So this is the equation. So that is the net current coming in to the node 2. And this is equal to the net current going out. This is V2 into 40 because it is given in Siemens. 40 V2. Okay, the equations.
अभी बस क्लास खत्म होने वाले 5 मिनट बचे.
Okay. Okay. The node 2 equation and node 1 equation. So now you have to solve this. Again, a complex solution of V1 and V2 is required, where the coefficients of V1 and V2 will be complex and the solution has to be found out. So what is the solution?
Is the
V1.
angle 23.3 degree.
Which one?
In V1.
Magnitude?
V1.
Magnitude?
1.062.
1.061.
So solving the above equations, you basically get this. So you have to practice these numericals. There is no escape route. Okay, so first is writing the correct equation.
Equation I have got correct, but the answers I am not getting.
So you
Yes,
check,
sir,
maybe my
actually.
huh?
Yes, sir.
Sir,
My answer is wrong.
that 50 minus 90 degree angle is written. We can write it as minus 50 j cap, minus 50 j.
Yeah, you can write. Ultimately,
Then
you have
I
to
am
write.
solving it using Cramer's rule.
Ultimately, you have to do that only.
Sir, I did the same equation, solved it using Cramer's, but not getting very much difference in the answer.
I check if other
Sir, an
students are
easier
getting this
method
answer.
Cramer's rule.
Sir, I'm getting
There is
same.
an easier method for solving than Cramer's rule for these complex with the complex terms and all.
It may be
How we are
advantageous.
solving these
Which
equations?
method is advantageous? You have to find out. So you get this.
Okay.
So the value is so if you draw, and then this is the value of V2 also.
Sir, V1 1.0619.
1.0619. Okay, I have stopped in 2 decimal places. And then you can complete the phasor. So the first phasor is this is the V1 angle 23.3 degree, and then it is V2 at an angle minus. So minus is basically in the fourth quadrant, minus 50 degree, and it's basically here. Okay. This example is okay.
Yes, sir.
Yeah. So we will stop here today. And